we have already discussed some cases for the formation of images by convex lenses. There are similar cases for constructing ray diagrams, for obtaining images with concave lenses. Image formation by concave lenses. A ray diagram provides position, size, and nature of images produced by concave lens, based on the position of the object placed in front of it. Please note that, no matter where the object is placed in front of the concave lens always forms virtual, erect, and diminished image of the object. The table on your screen describes images formed by concave lenses for different positions of object. Let us explain each case of image formation by concave lenses. Case 1, when the object is placed at infinity. When the object is placed at considerable distance, we can say that object is placed at infinity distance. When the object is at infinity, then all the rays from the given point of object becomes parallel to the lens after traveling long distance. In the figure, all the incident rays are coming in parallel to the principal axis of the concave lens, and after refraction passes through the lens, and all the refracted rays are diverging away from one another and not actually meeting at a point. But when the diverging rays are refracted backwards, they appear to meet at focal point f1 on the left side of the lens, which is also on the same side of the object. Thus, the image for infinite object is placed at the focus f1. We observe that the image formed is highly diminished and point-sized. So, when the object is placed at infinity, the image is formed at the principal focus f1, on the same side of the lens. The image formed is highly diminished, virtual and direct. Case 2, when the object is placed between infinity and optical centrome of the lens. Here we have a concave lens with the optical centrome, and f1 and f2 are the principal focuses of the given concave lens. A ray of light QD, which is parallel to the principal axis, enters the concave lens at the point D. According to the first rule of image formation by concave lens, the parallel ray QD should appear as coming from focus f1 after refraction, and goes in the direction dx. Now dx is the first refracted ray, appears to be coming from focus f1, the second ray of light starting from the same point q, and passes through the optical centrome of the lens, after refraction goes straight in the direction y. Thus y is the second refracted ray. The two refracted rays dx and y are diverging with each other, and appears to meet at a point q inverse on the left side of the lens, only when they are refracted backwards. Thus q inverse is the virtual image of the point q of the object, and p inverse q inverse gives the complete image of the object pq. Here we observe that the image formed between focus f1 and optical centrome is smaller than object size. So, when the object is placed between infinity and optical centrome of the lens, the image is formed between principal focus f1 and optical centrome. The image formed is diminished in size, it is virtual and direct.